Okay guys, welcome back. So in the last video I talked to you about powers and indices. So in this video I'll be taking you with some examples. I'll be illustrating with some examples in order to increase your understanding of powers and indices. So let's take some examples in this video and in the next video. So first of all, let's first take a simple example. So you can say, alright, so let's say that you have been given something like this. Now what if now 9, you have been given 9 over 36, no, I'll take 49 whole thing to the power half. Now we have been given something like this. Now you know that you can directly solve this. You can directly solve this if you have been given something like this. So the easiest way to do this is to make a power of 2 or a power of a multiple of 2. Now what I mean by power of multiple of 2 is that you can make this one as something to a power 2 or something squared, and you can make this one something squared, or else you can make this one something 4 times, right? The exponential is 4 or 6 times, 8 times, which are multiples of 2, so that multiple of 2 or that multiple of 2 will cancel off with this half to produce definite and integer indice. So I can easily write, now if I take something like that, now you know that 9 and 49 are 3 squared and 7 squared, and also 9 cannot be further simplified than 3 squared as a multiple of 2, as well as 49 cannot be further simplified as a multiple of 2. So the easiest way to write this is that 9 as 3 squared divided by 49 as 7 squared whole thing to the power half. So now you can do this in 2 ways, either to make a this whole term inside this bracket as a square, as a whole square, or you can take individual. So I'll do it in both ways. So my first way would be to make it a whole square. So 3 squared by 7 squared can also be written as 3 by 7 whole thing squared, and that was the term that was inside this bracket. That was the term that was inside this bracket, 3 by 7 whole thing squared, and now another half remains here, to the power half remains here, and this 2 and this 2 will now cancel because 2 times half is 1. So 3 by 7 to the power 1 is 3 by 7. Right? 3 by 7. So that will be the final result. Right? The next way is another simple way, is that if you get something like this, right? If you get something like this, 3 squared by 7 squared whole thing to the power half. So what you can do is that now you can say, take the individual roots, right? Take the individual roots, so that this is also equal to 3 squared to the power half divided by 7 squared to the power half, right? 3 squared to the power half and 7 squared to the power half. So 3 squared to the power half is again 2 times half is 1, and 2 times half is 1. So 3 to the power 1 is 3, and 7 to the power 1 is 7. So again you will get the same result, but it's another way of taking this one. So if it's another way of taking the answer, but actually in this problem you don't need actually a concept in which you need both ways, right? You need only one way, but there may be several questions, right? Several questions, and there actually exists some questions in which you can use only one thing, because this is just a simple example. But if you are given something where you have to deal with integers, the powers as integers and fractions and decimals. So you have to convert these. You can't actually sometimes convert these in the case of multiplication of indices. So you have to use either way. And in this example, you can use both ways, but as I mentioned, in some examples, you can use only one way. So let's take another example. So you can take something like that, similar example. So let's say 624 divided by, so it's 625 divided by 1296 to the power 1/4, right? 625 divided by 1296 to the power 1/4. So if you are given something like that, so as I mentioned in the first example, what you can do is that you can make 625 as a power of 4. So that power of 4 and this power of 1/4 will cancel out. So we saw that a little while ago. So if you are given something like this, this power 2 and this power half will cancel off, right? This power 2 and this half will cancel off. Similarly here also, this 2 and this half and this 2 and this half cancel off. So you can do a similar thing here. So you can do a similar thing here. Either you can make this one a power of 4 and this one another power of 4, right? Or power of 4. So actually, if you're solving this, you don't need to make this one an exactly power of 4. And if you make this a power of 4, you don't need to do this one as don't need to make this one or arrange this one as also power of 4. So this can be something to the power 4th and this can be something to the power 8 or 16, right? You don't need the actual way to the powers inside these brackets of these two, the numerator and the denominator, to be equal. So what we are doing actually is we can actually we don't know the powers of quarter powers, right? Quarter powers, half power, quarter power, 3/4, 1/8, 1/16, something like that, we don't know. So what we do is that we know the powers of integers. So 5 to the power 3 is 125, right? So 3 to the power 3 is 27, something like that we know, but we don't know actually the quarter powers of some ordinary, some strange ones like this. So you know that the quarter power 4 to the power half is 2 or minus 2, but if you are given something like that, so if you sometimes you may know, but if you are given some large term to the numerator and a large term to the denominator, or an extremely small term to the numerator or to the denominator, so it's actually hard if you are given some fraction like this. So what we do is that to eliminate this fraction, what we do is that we form a power in which both the numerator and the denominator have integer powers. So to make that, in this video, in this part of this video, in this example, what I'll do is that I'll write both these as a power of 4. So 625 is clearly 25 times 25. So 25 is 5 squared. So 5 squared times 5 squared is 5 to the power 4. So you can write this one as 5 to the power 4. This whole thing we have 1/4 to the power divided by. So how can we write 1296? So you know that 1200 is 30 times 40, and you have to get a 6 here. So you getting a 6 is either 1 times 6 or 6 times 6, but this has to be a complete square or a complete something to the power. So in order to get this, you can say that this is equal to, so 31 times, so this should be between 30 and 40. This should be between 30 and 40. So the two numbers actually they are equal and they should be between 30 and 40, because 30 times 30 is 900 and 40 times 40 is 1600. So 1296 is between 30 and 40. So the two values that multiply into the product of two values that make 1296 should be between 30 and 40. And you can see that we want to make either this a complete square or something power of a multiple of 2, either this has a power of 4 or a power of 8. So what we can do here is that we can say that 1296 is clearly 36 squared. So 36 is 6 squared, So 6 squared to the 6 squared times 6 squared is 6 to the power 4. So 1296 is 6 to the power 4. Now, as I mentioned, there are two possible ways to get a 6, either 1 and 6, because we need a complete square here. We can eliminate 1 and 6. So the only two combinations are 6 and 6, and they are equal. So the values should be 36 and 36. So 36 is 6 squared, and again 36 is 6 squared. So 6 squared times 6 squared is 6 to the power 4. So as I mentioned in the last example, you can do this in two ways, but I will do it directly now because I mentioned you a similar example a little while ago. So you can say 5 to the power 4 to the power 1/4 is clearly 5, and 6 to the power 4 to the power 1/4 is 6. So this will solve to 5/6, right? So those are two examples in which power and indices are used, and in the next video I'll be explaining, or I'll be introducing you some complex examples where powers and indices are used. Thanks for watching this video, and see you then.